ओके, तो एक बार देख मेरी ऑडियो कैसे पकड़ रहा है, ऑडियो कैसे नहीं। एंड आई बिलीव इट इज कैप्चरिंग प्रीटी वेल। तो एक बार देख मेरी ऑडियो कैसे पकड़ रहा है, ऑडियो कैसे नहीं। यप, डिलीट इट, डिलीट दैट। ओके, तो एक बार देख मेरी ऑडियो कैसे पकड़ रहा है। हेडफोन ठीक है, वो सही है। बैकग्राउंड थोड़ा सा ब्लर कर चुका हूँ मैं, दैट इज़ गुड। एंड माइक्रोफोन जो है वायरलेस है, बंद कर दो। Okay, so what is the use of clock in the synchronous communication like SPI?
Hey, hello Amit.
Hi, hello.
Yeah, how are you?
I'm fine. How? What about you?
Yeah, I'm good. Can you turn on your camera?
Okay, I will. Am I audible clearly?
Yeah, you are. Uh, how was the day?
Yeah, preparing for the interview.
Okay, good. Start introducing yourself.
My name is Amit Rajwakar. I am currently in a final year of my bachelor's degree, computer science engineering. From the past few years, I have been really interested in the embedded sides, and I have worked on many projects like workflow devices, institution management devices, and uh, MP Pulse device. And I am currently focusing on embedded sides and really interested into see how hardware works and software controls the hardware. And I am looking for an opportunity to increase my embedded skills as well as contribute to a real cause.
Okay, sounds great. Yeah, let's get into your project. Can you explain your why FDM 3D printer?
FDM 3D printer, yeah. So basically, I have used a developer board named Arduino Mega, okay, for the main controller board, in which there were maybe like three axis, three motors, and one stepper motor for the extruder, and there were stepper belts. Are you asking about the hardware or the firmware
You
side?
can
What?
you can tell both.
Okay. Have you
Briefly
start?
introduce about your project. Yeah.
Okay. So basically, in the hardware side, there were four stepper motors, three stepper motor for the axes, X, Y, Z axis to move the printer head, and one extra motor to push the filament inside the heater. And in the firmware side, I have used an open source 3D printed firmware known as Marlin, but Marlin is pretty slow. That's why I have swiped the motherboard, the more processing power. Basically, motherboard is just to execute the coordinates on the printer. So I have added Raspberry Pi, which does the heavy computing, and the Raspberry Pi tells the microcontroller that what to do on the printer, thus increasing the speed and communication, because Raspberry Pi has a wireless interface but Arduino Mega does not have. So previously I used to do by using a SD card or a serial communication by using a USB cable, but that was pretty hectic. So I have switched by using Raspberry Pi. I can connect to a Wi-Fi port on the, and on the web page I can manipulate the control the printer by using that.
Getting. May I know what is the purpose of Arduino here? Just to control the motors, right?
Yeah, previously before adding the Raspberry Pi, the Arduino Mega was the brain of the 3D printer, because without 3D, without the microcontroller, it cannot work, because the G code, basically the file which we give to the printer, is in the XYZ format, the coordinate format. The coordinate need to be processed based on the printer specifications. That's why the Arduino Mega was the brain of the 3D printer. But since I am added a Raspberry Pi, so Raspberry Pi is the brain now, and Arduino is just a controlling body, like nerves, you can say.
Okay, okay. Uh, I need some clarity over here. Like, because I'm curious about this.
Okay.
You have used Raspberry Pi and Arduino over here. You have shifted all those main logic in the Raspberry Pi. Still, why you want Arduino over here?
Why do I need? Because I cannot add direct. The stepper motors are, there are, I will tell you components of 3D printer. There are four stepper motors. There are two heating elements, one on the bed, one on the extruder. There are maybe like three switches, buttons, which tell you the coordinate. Basically, the when motor starts from zero, but there if assume करो कि वहाँ पे this is the start of a motor. If motor goes here and comes back, but if there is no button here, so motor cannot tell that it is end. So here is the button. When motor touches the button, it will get a notification or a command that it's a zero coordinate. Basically, but there are many components we cannot directly add onto the Raspberry Pi.
Okay,
That's why I have using a Arduino in between them. Arduino Mega has a some motherboard component that is specifically made for 3D printers, that allows you to connect many components onto a PCB, and that PCB connected to a Arduino.
okay, getting. I'm getting right now. Yeah. What is the challenge that you have faced during this project?
Major challenge was to source component because I was really not think like मुझे लगा नहीं था कि इतने सारे components लगेंगे, but at the end like फिजिकल स्ट्रक्चर जो होता है वो प्रॉपरली अलाइन नहीं हो रहा था. मेजर प्रॉब्लम तो वही था बिकॉज इन द 3D प्रिंटर द फिजिकल स्ट्रक्चर शुड बी रिजिड because if 3D printer does not have a rigid body, so it will print sluggish. The If I print a cube, their angles will be off. And second point was the calibration because it is using like old firmware because I had a Arduino Mega that was really old, like 5-6 year old, that was borrowed from a senior. So it was pretty old. So I have used, instead of using latest firmware, I was using the old firmware. So it was giving shit quality of print. So I need to really calibrate it.
Getting did you write the firmware everything by yourself, or you sourced from internet?
Oh, okay. The firmware side was like this. The open source firmware just give you the general idea. We need to tweak according to your printer because every printer is different on based on your size, based on your XYZ height. Mine was 20 centimeter XYZ. Okay, it can print 20 centimeter cube volume basically. So I need to tweak that according to, and many printer does have heating bed and extruder. So based on the components, we have to tweak the firmware.
Okay, getting. Are you good with Fusion 360?
Yeah, pretty well. Yeah, I have created like a two, three, majorly one product fully and two, three here there projects.
Okay. Yeah. Using Fusion 360, you created some 3D models and you did a 3D printing.
Yeah, that's the main goal behind learning the Fusion 360.
Yeah. Getting. Okay. What about small navigation system?
About mall navigation system. Okay, this was the my project 6 months previously. 6 month the 6-6 महीने पहले मैंने बनाया था. It was basically because I come from tier 3 village, and when I moved to a college there were 2-3 malls and I got to explore that. And when I got to explore that, I really didn't know where to go and where to find stuff. So this was the problem statement I faced. I thought there is a gap and I could build a product around it. So in our college, every 6 months we had a workshop around uh, emerging technologies. So I have in our college we had a workshop around Raspberry Pi. So I have took that. In the workshop, they teach little bit of Raspberry Pi basic stuff, and at the end of the 1 week workshop, at the end of the day, they tell you to build up one project in the next 3 months. Okay, while doing college.
Okay.
So that was my project, mod navigation, in which there are 3 buttons. Can I show you the picture of it?
Okay. Yeah, you can share your screen and you can go on.
Okay, wait a minute. My screen is visible.
Yeah, it is.
Wait a minute, I will show you. This one. So basically there are 3 buttons. The first button is for voice input because if you want to talk to this bot, you need to press that button and you can talk. Like if I want to go to, okay, I will ask him like, if I click the first button, I will ask, I want to buy Parle-G, where is it? Then he will reply, it is in the section number 5, aisle 5. It will tell the location. Second is the image input. If you want to buy a specific product, you can show product to a camera. Here is the camera. Earlier, actually, here was the camera. I was going to use the Raspberry Pi camera, but
Okay.
I did something. The camera was burned from my side, so I removed that. Instead of putting camera, I have put their microphone, and this is the dummy one. Actually, this is the dummy camera that was I burned, and this one is the microphone. Now, if you press the button, he will ask you to put the product you wanted to search in front of camera, and he will tell you. I will show the video of it. The starting camera, initializing camera. capturing image captured. The
So
product I showed was this magic masala.
hmm,
Image sent. It is basically processing onto the Raspberry Pi. Raspberry has all the stuff behind, and it will show you section food, rack middle. Name is the magic masala. Price is this.
hmm,
This was the main
okay.
project I have built. And this QR code actually, this where is it? Wait a minute. This QR code also, if you scan this QR code, you don't need to talk to this bot. You can access a web application onto your mobile, so you don't have to talk around it. You can view on your mobile and roam around in the mall.
Okay. Uh, how many people are in the team, or is everything is done by you?
Actually, there were three people, I, and there are two girls were there, because in our workshop, the workshop is generally given. This is the hardware workshop. Okay, the workshop is divided by the department. I am in the computer science department. It was given to EXTC department, and I was the only person of computer science in the EXTC,
Hmm,
and there were two girls where they were not in any of the group, and so instructor told me to take them into my team. So basically the project is done by me, but officially there are three people.
okay. Sounds great, man. It's really looking amazing. Uh, yep. Can you show your Fusion 360 skills that you have done?
Okay, I will show. Wait a minute.
Yeah.
Is my screen is visible?
Yeah, it is.
Okay. Basically I'm currently working on a workflow device. For that I have majorly used the Fusion 364.
Okay.
It is
Uh,
this one. It is a 3D printed macro pad kind of stuff.
Matrix keypad, right?
Yeah, you can say that. Yeah, definitely.
Uh, yep. Even you are learning it from some YouTube channel.
Actually, I saw inspiration from a work louder company that are like a UK based company.
Hmm.
I will show you. Wait a minute. This was the whole inspiration. Yeah, this is the company that I took inspiration from. This is the work louder company. They are working in the same industry from like 5 to 6 years, and I got the inspiration when I was building this project. Wait a minute. I was working on the RFID college system, and there were a keypad. Okay, while building the keypad, I was scrolling, and then I got a reel from these guys, and
Yeah.
I thought like, why can't I build one? No, instead of thinking why can't I build one, I was like, I want to buy this. I got to search, and I get to know that there is no Indian version of it. So I thought there is a gap in the market. So why can't I build one? So yeah, that was the reason to build that Blocky.
Yeah.
The name of
So
the product is
you
Blocky.
designed PCB and
Yeah, everything,
Fusion
everything.
360. Okay.
Yes.
Very interesting.
Wait a minute, the Fusion 360 is launching.
But you are from computer science background, right?
Yeah, I'm some computer science background.
How did you got interest in this field, embedded mechanical all this stuff?
Basically, actually, I was interested in the embedded sides, but my father did not like the stuff I do with the hardware. From like eighth and ninth, I was into the hardware. I doing electrical stuff at the home, doing motors and all that childrens do, like buying a electrical car and taking it apart in 2 3 days, removing all the parts and making something else out of it.
Mm.
That was the main interest started there. From there, I have worked till here. This was the PCB I have manufactured basically.
Great, man.
Wait, is Fusion 360? Okay. It is opening.
Yeah, it will be a bit slow.
Yeah, the film is like a system resource intensive software, so it will take a while to open.
Mm. Are you getting any background noise from my side?
No.
Okay.
Can I ask you what was your stream in the bachelor's degree?
Yeah, I'm from electronics and communication engineering.
EXTC,
ECE.
ECE. Okay.
Yeah.
Okay. This was the 3D model I built.
Mm. Okay.
Wait a minute. I will show you the each component. So basically, this is the upper body.
Mm.
This is the upper body, and this is the transparent part which allows you to spread the LEDs, because behind it
Mm.
there is a part to put LEDs. So basically, it will shine through the transparent part.
Mm.
This one, I have put on my logo there, and
Okay.
these are the encoders. Actually, this is the old PCB. I will show you the new PCB that I have put on. Uh,
Can you open your
yeah,
keypad as well?
yeah,
Uh,
yes, I have worked on the keycard also. This is the new PCB
mm.
that has space to accommodate encoder and all. I am using like RP2040 or developer board that is like pretty small. This small is it is,
Okay.
and I am using mechanical switches for it. And these are the encoder.
Yeah.
Before working on the blockade, I was into a modular keypad that was going to be look like this, but technically it is pretty hard to make it. I'm currently not working on it, but I would like to work on it. This was the initial idea to make like this. Okay, these are the all modular part basically.
Mm.
You can attach by using pogo pins. That was the whole idea behind the making.
Mm.
But I have fabricated this part and this part. These two parts where I built it basically. But the problem was the communication. I was not able to figure out the communication between them. So
Mm.
that's why I scratched this project. But this is on the pause, and
Mm.
that's why I built the this one.
Yep, man.
This one. So currently I have
Yeah.
showed you this
I
one.
can see. Yeah. Okay. Let's come back to our interview.
Yes.
Uh, yeah. Uh, can you say me about protocols that you know, like SPI, I2C, and UART?
Yeah. I need to explain it or just need to state that what you.
Just explain what is UART and what you know about UART.
Okay. So basically in the UART is the UART, Universal Asynchronous Receiver and Transmitter. It is a asynchronous communication in which there are only two wires, TX and RX. It is usually used for like programming the IC, I believe. And there is the SVI, which is a serial communication, in which there are four wires. There are MISO, master in, slave out, and master in, slave out, and slave master out, slave in. There is a cycle and chip selection. Is there? There are four wires to communicate. It is SPI is pretty fast. It is used between the CPU and the memory, and it also used in display, I believe. And there is I2C, which is integrated circuits, inter-integrated circuits, in which there are three wires, I believe. There is a wait a minute, I2C. Oh yeah, there is two wire SDL and SCL wire is there, and there is another wire that is clock, and it is used for peripherals like display. We can use to attach sensor and all. The most popular version of
So
I2C is
what is
like
it for?
LCD display.
Okay. Uh, the thing I2C only has two wires.
Okay, two
SCL
wires.
is the clock. Okay. There is SCL and SDA. SDA is database and SCL is clock, and it is multi-master and multi-slave optical. Ultrasound is a master can read or write. It can't do both at the same time. But your doesn't have clock. It works with baud rate.
But red, yeah.
Okay. What mean by baud rate is symbols per second. Each symbol, sometimes we can assign symbol as 1 bit, sometimes symbol as 2 bits. Depends on the symbols and baud rate we will be using to communicate between two things. In olden days, UART are used to between computer and the printer. Okay, and I2Cs are used in the single board. Like we have our device, and inside our device we need to communicate between some sensors, and it should be half duplex. Depends on the scenario. At the time, we will be using I2C, and for SPI, it is like single slave, single master, and multi slave. It has 4 wires, and SPI is bit faster than I2C because like I2C need to if I2C want to communicate with some slave, it will be sending its address of the slave in the database. Okay, if
Okay.
slave belongs to that ID, it will respond it. It will acknowledge it. Then only I2C master will start communicating. But in SPI, we having only one master and there are multiple slaves. And SPI has chip select line. It will directly select which uh, slave it want to split.
Okay. Instead of
Because
address.
SPI is bit faster than I2C.
Okay. Got it.
Okay. Instead of there is no address, and here in I2C there will be address and acknowledgement, some cycles will take. But SPI, it is one of the reason.
Okay.
It is one of the reason that we can justify SPI is faster than I2C.
Okay.
Uh, yep, man. Uh, what do you mean by ADC?
ADC is analog to digital converter. It is used to convert the signals of analog sensors to connect to a microcontroller. It is used for converting the digital signal, analog signal into digital.
Okay. Uh, yep. What is resolution over here? Why do what we need to consider number of bits for ADC? What is the purpose of it?
Actually, I have no idea. Can you give a little bit hint?
Yes, ma'am. Like resolution in the sense number of bits. Like for example, if 2 power 10, we will be having 0 to 1024 levels. My 5, for example, my microcontroller input pin will receive 0 to 5 voltage. I want to split this 5 voltage into steps. Getting? And
Mm, no idea. I have no idea.
yeah, yes, ma'am. This by splitting by dividing those the 5 voltage with this 2 power 10, or it is depends on the resolution, how much resolution that IC is supporting. While dividing that, we will be getting some step value. For each step value, we will be assigning the digital value.
But how we divide it?
How we divide it? Yeah, 5 voltage is V max. It will be divided by 2 power 10. If it was 10 bit resolution, it will be divided by 2 power 10. If it was 16-bit resolution or 32-bit resolution, it will be divided by 5 divided by 2 power 32.
Okay, so basically it depends on the IC sensing power. Am I correct or wrong?
Yeah, okay, they will be configuring the ICs. While configuring the ICs, while manufacturing, they will say yes, this IC will be working at this values, this IC will
Okay,
be
got
working
it.
at this values. And sometimes some sensors we will be mentioning. I want some accuracy, so my step size should be more smaller. So I will increase my resolution. Number of levels will be increasing.
Okay. So what was the concept? Resolution overflow.
Resolution we can study about step size, resolution, and ADC concept. How ADC, uh, how voltage is mapped with the digital value.
How voltage is mapped with?
Digital value.
Okay, thank you.
Yeah. For example, how should I say? We have 5 voltage. I am dividing it with 10.
Okay.
What I will get? 5 divided by 10.
5 divided by 10, 0.5.
0.5. So my 1 will be pointing to 0.5. Digital value 1, it will be pointing to 0.5. Digital value 2, it will be pointing to 0.5 into 2.
Okay.
Digital value 3, it will be pointing to 0.5 into 3, 1.5, like that. Then digital value 10, it will be pointing to 5 voltage. Getting?
Yes, I'm getting. Sounds good.
Yeah, this is how it works. If I increases this 10 into 20, then it will be 0.25.
Okay.
See,
Hmm. The
my
sensing
accuracy
power
is
will
increasing.
increase. The
Accuracy
step
is
count
increasing.
increases. Thus, the
Yeah,
accuracy will increase.
yeah, accuracy is increasing.
Okay.
Zero before we only can measure 0.5.
And now we are
Now
0.25. Got it.
0.25. If I
Hmm.
increase this number of bits, still my accuracy will increase.
Hmm. But it will cause like a CPU, like it will put a load on the CPU, I believe.
No,
No.
no, not like that.
Okay.
Okay. Uh, what do you know? Any idea of PWM?
Yeah, PW like pulse width modulator. It is used to control the brightness of LEDs and all.
Do you know how it works?
Basically, it works by changing the it basically it will very fastly turn off or turn on the voltages and thus reducing the frequency or reducing the voltage, thus decreasing the brightness, something like that, I believe.
Okay. Here, PWM is used to achieve average voltage.
Okay.
And do you know how much will be the our voltage in our microcontroller pin, output pin? How much voltage will be in the microcontroller output pin?
3.3 volts, I believe, or 5.
Yeah, it will be either 3.3 or 5. Okay. Let's take a scenario. There is a motor. I want to control the speed of the motor, and my motor requires high voltage to run in full speed. If I want to control the speed of the motor, what should I do?
Like we can put a ADC module there,
Mm,
the PWM model there.
now, yeah, we want to put PWM. Now I want to reduce the speed of the motor. My motor will run at full speed when I am giving 5 voltage.
And if we give lower voltages, it will gradually decrease the speed.
Yeah, that is the motive of PWM. What PWM will do? It will frequently turn off and on, so it will provide average voltage.
Okay.
For example, if the pin is 50% of time is on and 50% of time is off, frequently it is happening, then my output voltage will be 2.5.
Okay. The speed will be 50%.
Yeah, like on time and off time. Depending on time and off time, we can achieve the average voltage that we require. If I want to dim the LED, brightness of the LED, and at 5 or 3.3 voltage, my LED will be glowing at uh, full brightness. Then I want to dim gradually. So I will be increasing the on time and off time. Getting?
Getting. Understood.
Yep.
PWM average values, no?
Ah,
Okay.
the thing I am mentioning now, just note it down. Do some homework on it. If you get selected for the next round, okay,
Okay.
they may ask you these questions.
Okay. The resolution I have written, but what about the DWM? PWM, sorry.
PWM is equal to
Hmm?
uh, duty cycles by T on plus T off.
Off. Okay.
T on plus T off is one period. You can study about PWM. If you go with ChatGPT and ask how that works, I
Hmm.
think you get a clarity why we need PWM right now.
Okay, I will.
Yep, man. Yeah. So, what is it PWM? What is timer?
The timer is the clock that runs inside a timer in the CPU.
Hmm?
Generally, like to communicate in the SPI, there is a clock on the based on the timer they are working, I believe.
Okay. Uh, no.
Example
Uh,
like 20 in the ESP32, the clock cycle is 125 megahertz. This is the timer.
okay. Um, Timer is it is used to count the clock pulse. Getting? we will
Hmm.
be having what should I say that oscillator.
Oscillator, huh? Yes. The quartz
It will
oscillator.
yeah it will produce clock pulse. So we want to count those clock pulse. For that purpose, there is timers. Same. Even in timers, it is depend on number of bits. Okay.
Okay, got it.
For each clock pulse, uh, one value will be increased, and if the bit is overflowed, for example, 10-bit timer, let's assume, for example, it is a 10-bit timer, my value will be 0 to 1024, and for each clock pulse, it will increase from 0, 1, 2, 3, 4 until 1024. If it reach 1024, it will uh, trigger ISR interrupt.
Interrupt.
Inside interrupt, yeah, inside interrupt, we need to count how many times the timer is triggered as. There are some calculations. It depends on clock frequency. It depends on number of bits and pre-scale up, post-scale up. There are some stuff. It depends on that. We need to count how many times the overflow happens, and we will finalize it is equal to 1 second. For example, if my ISR triggers for 20 times, then it is equal to 1 second. And inside the program, I will use it as a seconds. Getting?
Timer is non-blocking, I believe. Delay is blocking.
Yeah, it is.
Okay.
Yeah. And do you know what is interrupt?
The interrupt is the like a uh, signal to a CPU to stop everything and look at this. It triggers ISR, interrupt service routine.
Hmm?
It is used for like timer and all. If you example is like if you there are two methods to send a signal. There is a one method is polling. If you have a button and there is in the polling situation, CPU will constantly observe the button is pressed or not. But in the interrupt one, whenever we press the button, it will cause an ISR and it will CPU will register the button.
Okay. What is interrupt latency?
Interrupt latency. The latency between the actual interrupt, basically the cause of an interrupt and actual implementation of ISR.
Hmm. Okay. Like interrupt latency is right now my CPU is executing my program counter is pointing to my main function. Okay. Now interrupt arrives. My CPU will shift from my main function to ISR function. This gap between this, right? There is some gap between some main function to ISR function. That is interrupt latency.
Okay, got it.
The time taken between the shift. Yep, man. And what more? Have you? Yeah. Uh, while pressing button, what are the things that we need to consider? How will you find exactly button press? All those stuff.
Okay, so on the hardware side, we need to connect actually need two wires, two GPIO pins,
Hmm?
and if you connect them both, it will cause an in the function we need to specify which GPIO pin we are preferred for the button, and based on that, it will detect and cause IRS.
Okay. Again, I have something. Why we want to GPIO pins? I'm
Actually,
asking.
why do we
Why?
need two GPIO pins?
One pin will be for ground and another pin will be control to the microcontroller, right?
That also can be do. If there is only single button, we can use both GPIO pin. If for like multiple buttons, like if you want to use many buttons, like between ranges from 9 to 15 or many more, we can use the matrix also,
Hmm?
in which we can assign,
Like,
for example, if we want 9 buttons in the matrix
hmm,
form, we can use 6 GPIO pins,
hmm,
3 for rows and 3 for column, and that will make a matrix of 9 buttons. And based on that, we can trigger button for if, for example, assume case 2 comma 2 GPIO pin, for example, second row GPIO and the
hmm.
second column GPIO is triggered. That means the fifth button is triggered.
Okay. ask is, while pressing button, there will be some uh, bouncing will happen.
Debouncing, yeah. To avoid it, we can use diode, single way diode, Zener specifically.
Zener diode. Okay. Like, I think the Zener diode won't work over there. Uh, can you justify why we want Zener diode over there? See, debouncing effect means what will happen now? If you are pressing the button, huh? After you released it, again it will touch the pin.
By releasing it.
When you are pressing, it will touch the pin. After you release, there will be some frequently vibration. It will touch and release, touch and release. You need to avoid that. At that point, if you are putting Zener diode over there, what what things be happening here? Nothing, na? Zener diode, what is the purpose of that diode? It will allow current only in one direction. So how we will be overcome the situation? In hardware, we can add some RC circuits, like we can add some capacitors over there. When you press the button, the capacitor will be fully charged and it will uh, activate the pin. It will mention it is pin button was pressed. When it was partially on and off, my capacitor will not get charged. That is one thing. In software side, we can have some delays. For example, my button, if the pin should be high until uh, 0 0.5 seconds, then only I will consider it was button was pressed. See, when I am pressing the button, my pin value will become 1. If there is bouncing, my value after releasing it, it will become 0 1 0 1 0 1 frequently. I don't want that. So I use some delays over here, blocking delay or non-blocking delay. So I can avoid that debouncing effect.
Okay, got it.
Yeah, yep, man. Uh, Something that I want to ask: how good you are in C programming?
C program, like I can say intermediate, like not have. I'm not really much into C programming, but I have given a last from the last 1 or 1.5 month. I'm really working on it. Currently at an intermediate state, you can say.
Yep, man. Uh, in C programming, what is volatile?
Volatile means like these are the data types that can change at any time, and this form sorry the compiler know that value can change, so it does not optimize them.
Hmm, good. Why do you want constant?
Constant are the basically constant are the data that should not change, assuming like clock cycle and all. We don't want it to change by anything, any function. So that are the we assign const to it, so it will not change inside a function or inside a program.
Okay, don't be more tense. Relax. Okay, no worries. If you don't doesn't know answer, I'm here to teach you. Okay, don't get stressed that you are unable to answer. Try
Hmm.
to take it. Getting?
Okay, thank you.
Yeah. Yep, man. Uh, you are creating a constant variable in memory segment where that variable will be stored.
In the flash memory or
In
yeah, I believe flash or RAM.
okay. In let's see only RAM. In RAM there are four memory segments, right? Do you know what are the four memory segments in RAM?
For memory, types of memory you are asking in the
Hmm. Yeah, go on.
there is a EPROM, there is a flash memory.
I'm not
uh,
asking about that.
okay,
Like stack segment, text segment, and data segment, heap segment.
I only know about stack and heap.
Hmm.
In the stack, the basically the in the stack values are automatically stored, and in the heap we actually allowed use of functions like MALLC, basically allow memory to a function in the heap.
Hmm. Okay. Yeah. Uh, the thing const it will store at data segment.
Okay.
Stack segment will be created when a function is called, and static. and constant. Both will be stored at data segment, and malloc and calloc, it will be stored at heap segment.
Heap segment.
And other uh, words, it will be textures like in printf, into in the bracket will be written now print a
Mm-hmm.
is equal to, this will be stored at text segment.
Text segment.
Yeah. Yep, man. uh, what is the difference between malloc and calloc?
A malloc and
Calloc.
like the maybe basically in the malloc, I only know about malloc in which we assign a memory to a specific function. After the function is executed, it will free that memory. I don't know about the calloc.
Okay.
Always free the memory in
Calloc.
the malloc one.
Mm, okay. If you are creating a runtime memory dynamically, you will be using malloc, calloc, and reloc. Okay. Malloc, if you are creating it, it will be initialized with garbage value. If you are creating a dynamic memory using calloc, it will be initialized with 0.
Okay.
This is the major difference both. And I think for malloc, we need to pass only one argument, and for calloc, we need to pass two arguments. These are the difference. Once you created the memory, before, when you need to free the memory, else there will be some memory leakage. You need to be safe with those pointers. These concepts consider dangling pointer, uh, I think wild pointer something. Okay.
Okay. Got it.
Yep, man. Can I ask you questions from analog electronics?
Actually, I have like you can ask, but I will try to answer it.
Mm, yeah. What is op amp?
What?
Op amp. Op amp.
No idea.
Okay. What is capacitor?
Capacitor is like a temporary storage of charge, and it will release based on the input voltage. It will store the charge for temporary basis, and it will release for once at all.
Okay. But it is not a correct definition. Just study all those stuff. Okay. Op amp, capacitors, resistors.
A resistor is like a opposing force to the current, and which oppose the current. If we like, if LED operating voltage is like 3.3, and if we want to use 5 volts, we can add a resistor in between them to use LED.
Okay. Uh, Another one question. I have LED.
Hmm.
Okay. Uh, in which pin I will, for example, I have red two wires, black and red. Black is connected with ground and minus terminal in battery, and red is connected with plus terminal in the battery. Okay. You know HW battery, right?
Yeah, I know, 9 volt.
uh, there are two wires, and I want to connect with LED. In which wire you will connect resistor and wire?
In the, I believe in the positive wire, because it will current flow from positive to the
Why
negative.
not in, okay, why not in negative side?
Because I actually don't know the current answer, but the logic behind will be like that. The current is
Like,
flowing
yeah.
from positive to negative.
Mm,
So we can put, if we put in the positive side, the current will first flow from resistor and then into the LED. But if we put a resistor on the negative side, the current will flow first into LED, that will burn the LED, and then in the resistor.
Here the concept is, see, current will flow if there is only closed path, then current is flowing from positive side to the negative side.
Hmm.
What happens if I am stopping the current before the it is entering into LED? There is, both are same. Anyways, I am stopping here. Uh, I don't know how to put in the words. Okay, it will work on the both sides. You can see some YouTube video, you will understand how
Okay.
current is working. Okay, and I will give you some topics, read on it. Even not for our company, if you are, want to become an embedded engineer, you want to at least these basics,
Okay.
basic electronic concepts like KVL, KCL. You don't want to study about the sums, just what that means.
Okay.
And
Definition of it.
Ohm's law.
Hmm.
Ohm's law, power.
Ohm's, Ohm's law, I know. I is equal to VR.
Oh, good, good. Okay. What is ground?
Ground basically the negative terminal, I believe. We can consider negative terminal as a ground
Uh, okay.
or a zero voltage.
What is the? Hmm, yeah. Uh, Ground is something like reference voltage.
Okay,
How you will be
reference.
saying this building is this much high from the ground, na?
Hmm.
From ground it is
Reference point.
ground it is 100 feet. From ground it is this many feet. It is the, so what we are saying it as reference voltage, and it is also a written part for the current. See, from positive terminal it is going to the negative terminal. We are giving a written part.
Hmm.
Again, your the electrons will go get into the battery.
Hmm.
Okay.
I have a question. Like ground will always be a zero, or it can be different voltages.
Uh, Actually, ground is not zero V.
Okay.
For our understanding, for reference voltage from 0 to 5 we will say. Either we can say it is like uh, 5 to 10. See, there are only 5 difference. Ground is 5, my voltage is 10 V. Then my actual voltage is 10 V.
Okay.
From 0 to 5 V, then my voltage is 5 V. From 5 to 10 V, again my voltage is 5 V only. See,
Hmm.
getting?
Getting. But the value of ground is different between the both.
Hmm. Yeah, but when we are studying everywhere, we will be saying it is 0 V for reference part.
Reference. Okay, got it.
Hmm? Yep, man. Even to be frank, I am not that much good with these analog concepts.
Hmm.
I know all those. I am. I know these fundamental things. I don't want to solve these problems and all. Okay.
Okay.
Uh, yep. Can you share your screen now? We will get into programming ground.
Okay. Tell me what I want to do.
Online C compiler. Write a program to add two numbers.
Okay, want to write two numbers. What are the numbers?
Get get input from the user.
Actually, I don't know I know the syntax, but I cannot write the code. Basically, the scanf is the function that we use to fetch the input from a user, but I currently don't know the syntax to write it.
Okay.
But I know the syntax to add two
See,
numbers. If I wanted to, I can show that.
yeah. Try it. If you can't, I will help you.
Because the scanf was done like
Hmm.
35 days ago in the beginner session, in the beginner videos. I don't really remember the syntax of it, but I know the function that we use to take input from the users, that is scanf.
Uh, okay. Check the chat.
Okay.
don't work like that.
Okay.
Scanners will return number of inputs will return one both. So it won't work like this one. Int a semicolon int b semicolon in the next line you want to get input from the user.
Well, I will actually work on the syntax side. I need to work on that because I need to revise it. It was like 35, 1 month ago I did it.
Okay. Uh, just skip this. Write a program to find whether the number is even or odd. I don't want the modulus operator here. Do you know any other approach?
What is the question actually? I don't get it.
Uh, Find the number whether it is even or odd. You
Okay.
should not use modulus operator.
Modulus. The divide operator, na?
I You should not use that.
Okay. So we can use the remainder one, the percentage basically. That will give you the remainder, and based on it is 0, it is divisible by 2. If the remainder is 0,
I am saying I should not use that method.
okay, we don't want to use that method.
I don't want to use. Is there any other method that you know?
There is a one method to divide it, and there is another method. There are two methods. One is the use directly divide to get the quotient, and there is another method to get remainder. So we can use the remainder method. I don't know the operator name, but I know the concept behind it. That is to get the
I don't
remainder.
want to use both.
Okay.
Yeah.
Uh, we can use for loop in which we
That is
can
modulus. That symbol is called modulus. Okay.
percentage one.
Uh, Percentage. So if you are using that, you will get remainder. But
Okay.
I don't want that method. I want by something by using bitwise operators.
Bitwise operator. I don't know. I need to work on it.
Yeah. Good. Yep, man. Uh, let's. You can stop sharing your screen. Uh, yep. You really did well, and your projects are too good. Okay. But one thing, you want to improve this embedded concepts. You want to
Okay.
know this thing. I2C protocol, SPI protocol, timers, counters, getting,
Okay.
and read about how CPU is working, fetching, executing, decoding, all this stuff. How memory is happening. If I'm creating this variable, where the memory will be allocated, those things you should be good with that. And am I going bit fast?
No, no, I'm writing it.
Yeah. And study about bit manipulation concept.
Concept. Okay.
And if you are really targeting this very seriously, you want to get into good companies, then study about array of pointers, pointer to array,
Array two pointer.
array of pointers,
Pointers. Okay.
pointer to an array.
So what is the use of it actually?
Like array of pointers means in an array you can save. Do you know? In
In the array,
array
we
of
store same data type basically.
wait, in array you are creating array. What that array name contains? What is the array name?
Array name at the variable, I believe. No, it is
Array name is base address.
okay.
Okay. It will be having the address of index 0, array of 0. Address of array of 0 is equal to array name. Both are same. And there is some in that same concept there is something called whole address. Arrays whole address. If I want to store arrays whole address, then I want a pointer called a pointer to an array.
To address that particular address.
I want to store the see, if I want to store integer address, I want integer pointer. If I want to store character address, I want character pointer. If I want to store address of the array, whole address, then I want pointer to an array. pointer to an integer, pointer to a character. Now I want pointer to an array. Getting?
Getting, got it.
Uh, I personally suggest you. I think there are 150 to 200 videos from Jenny's lecture.
Okay, what is the name of the
Jenny's lecture. Jenny's
Jenny?
lecture. She's
Okay,
uh, don't skip any of her videos.
okay,
Take notes. For sure, the notes will come up to 3 to 4 books.
okay.
Take it, and that in that way you can improve your C programming and chat GPT and ask questions to solve. And in don't leave DSA.
Hmm.
DSA also is more important. In DSSI, stack, linked list, queue, circular buffer. Most of the interviewers they will ask you circular buffer.
Surplus buffer.
Yeah.
But are you talking about this one? I will show you the screen. Wait a minute.
Mm.
This one.
Just a minute. Yeah. See. Please.
This YouTube channel.
Yeah.
Which playlist you want to add?
C playlist. It is bit older one I think.
What is it? C.
Ah.
C programming.
First start with C programming. Okay.
Okay.
See, you did these many projects, but you did more hard work. If you
Hmm.
say that you are not good with C programming, then see you created a great impression in start beginning of entry with your project. But
Hmm.
at the end, you are struggling with these basics. If you spend some time on this, really
Hmm.
you can achieve this domain. Get it?
Got it. Thank you. But I have a question because I'm from the IT branch. Is there a problem in going into this industry?
No, 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 not at all.
Because
Because
in my college, I have given like two interviews, but they were like asking, like, what branch are you from? I told them I'm from computer science AIML, and they told me like, no, no, it's not for you. You can go on. That's why I
uh,
asked you.
such things happens in some college, but in the entering into the industry now,
Hmm.
there are teams they have a firmware engineer. See, in embedded system, it is not only hardware plus software. Sometimes there are domains like embedded software engineer, embedded firmware engineer. So if you know that such things as protocols, PWM, ADC, and counters, timers, all the stuff.
And how much DSA is required for it? Like, what do you
Basic
think?
fundamental DSA,
Okay.
basic fundamental. Linked list, you want to know where how to add a node in between at last, how to delete that node, all those things. And
Hmm.
space complexity, time complexity, if you are targeting good companies. Okay.
Okay.
And in recursion, you want to know how what happens during recursion. And let me think. Space stacks, trees, then sorting techniques,
Hmm.
and searching techniques. Binary sort. There are some sorting techniques. Huh?
Okay.
I doesn't remember right now. Those things you have to study. First, yeah, keep this in mind. After completing this, get into Linux.
Okay. Embedded Linux and all.
Either embedded Linux first, or RTOS. Go with free RTOS.
Okay.
After completing, first complete C programming,
Hmm.
then these embedded concepts that I have told, then free RTOS. After that, revise these basic electronics.
Okay.
Okay. So since you
Basically, first I will learn C, then
mm,
you have currently told me the flow, na? Like first
yeah,
learn the C and then what?
C, after C programming, uh, you can start with this thing, embedded concepts,
Embedded concepts.
ADC, PWM, timer, button press,
Okay.
button single press, double press, long press, IMF interrupt,
Okay.
and there as well how matrix keypad works. Take one by one microcontroller, either STM32 or ESP32.
Hmm.
Better go with STM32.
Okay, the white one, na?
Hmm.
Okay.
Yeah, and practice bare metal programming. These things are called. First, you want to familiar with bare metal programming. Then understand what is bare metal programming completely. Later move to autos.
Okay,
Then
bare metal programming के बाद आटोस.
on ESP32.
Okay.
Okay.
What? Man, can I get your number for the guidance? Look, if I have a doubt and I can reach out to you.
That's actually true. I don't get this ongoing. I have did these fundamentals.
Okay.
Right now, I am just get into desktop things like system calls, processors, all this stuff. There are many things. There is no end to this because
Hmm.
every day you will be facing new challenges. You will be learning new things.
Hmm. Got it.
Got it? Yep, man. Nice to see you. Do you have any questions for me?
नो एज सॉल्व बिकॉज आपने पूरे क्वेश्चन सॉल्व कर दिए ना जितने मैंने पूछे आपको.
Sorry, I doesn't understand Hindi.
Sorry. No questions because the questions I asked you all you cleared that, so no problem.
Hmm. Yeah, how do you
Uh,
feel this interview?
yeah, it was good. Like
Hmm.
I get to know that what are the drawbacks, that what are the things I didn't know, that about
Hmm.
thinking I know that
Hmm.
basically. Yeah, so I need to revise on the basic stuff.
Hmm.
Mm.
Yep, man. Okay.
Actually, one
I
thing,
thought,
can you give me the number? Like, I want to stay in touch and I want to get guidance from you if I have any doubt.
yeah, you can. 95
95
double six
double six
double four
double four
double two
double two
39.
39. I will repeat the number 9566 double four double two 39.
Yeah.
Okay, I will message you. Okay, thank you.
Yeah, man. Bye.
Okay, bye. Fuck. Fuck. Ah, fucking hell, bro.